Welcome to the Daily AI Brief, the podcast where we delve into the latest innovations and breakthroughs shaping the AI landscape. Today, we'll explore exciting developments from Google, Moonshot AI, NVIDIA, and more, each pushing the boundaries of what's possible in AI technology. In the rapidly evolving field of artificial intelligence, data scarcity remains a formidable barrier, especially in domains where access to high-quality labeled data is limited. Google is aiming to tackle this issue head-on with its latest release, Simula, a reasoning-first framework for generating synthetic datasets. This new approach is designed to fill the gap left by traditional methods, which often depend heavily on large seed datasets or manual prompt interventions. So, what exactly makes Simula different? It employs a reasoning-driven methodology, which allows users to articulate specific characteristics of datasets they wish to generate, such as coverage, complexity, and quality. This is achieved through several controllable axes, including global and local diversification, the complexification of data structures, and rigorous quality checks. Unlike traditional models that require vast amounts of seed data, Simula's agentic model operates without these limitations, promoting scalability. The launch, evaluated across 5 diverse AI domains, shows significant promise. While specific size limitations haven't been disclosed, it's suggested that dataset size is unrestricted due to its seedless model. Moreover, tailored dataset properties, rather than mere volume, have shown to enhance downstream AI performance, presenting Simula as a practical tool for data-scarce environments. With improved downstream performance recorded, Simula's effectiveness emphasizes quality and customization over sheer data volume. However, like all innovations, Simula isn't without its trade-offs. Long-term effectiveness across all AI domains is still under assessment, and potential integration challenges with existing AI workflows may arise. Moreover, while its reasoning-first approach offers adaptability, rapid changes in AI requirements could outpace its capabilities. For instance, maintaining data quality over iterative generation processes remains a concern, particularly if the requirements evolve faster than the framework's adaptability. For those interested in exploring Simula, Google provides an extensive set of resources. Visit their official Google research page, twalm/research.google/blog/designing synthetic datasets for the real world, mechanism design and reasoning from first principles, UTM source OpenA. To delve into documentation, view shared datasets, or try the tool's data generation API to experiment across various AI domains. Practical steps involve reviewing the technical paper detailing methodology, testing Simula through Google's data generation API, and experimenting with generating datasets in diverse AI applications to ascertain adaptability and performance. In summary, Simula represents a leap forward in synthetic data generation, particularly for privacy-sensitive or data-scarce applications. It's a tool that not only promises efficiency, but also enhances the scalability and robustness of datasets for AI applications. This framework offers the potential to revolutionize how data supports AI training, enabling practitioners to craft tailored datasets that improve model accuracy and performance, while also opening doors to previously inaccessible domains. Immerse yourself in the world of collaborative AI with Moonshot AI's release of Kimi K2.6. This cutting-edge model is designed to tackle complex software engineering tasks through the power of agent swarming, scaling up to 300 subagents working in unison. Kimi K2.6 represents a significant leap from its predecessor, Kimi K2.5, which managed just 100 subagents. With the new model, the number of coding steps orchestrated jumps to 4,000, enabling it to engage in prolonged coding sessions spanning 13 hours. The model effectively utilizes agent swarming algorithms, enhancing efficiency in software environments that require extensive autonomy, including system monitoring and incident response. The technological backbone of Kimi K2.6 includes proactive agent deployment that strengthens long-horizon coding capabilities and an advanced orchestration engine that efficiently manages agent swarms. The model integrates seamlessly with developer environments thanks to robust APIs, supporting multimodal functionalities, and using advanced attention mechanisms to ensure speed and accuracy. On the performance front, Kimi K2.6 rivals and sometimes surpasses industry standards like GPT 5.4 and Claude Opus 4.6. Despite these promising benchmarks, independent verification of claims poses a challenge, and scalability might hit a practical limit due to resource constraints. Ready to try Kimi K2.6? Begin by exploring the official Kimi blog, kbpw.kimi.com/blog, Kimitors OpenA, for insights. The Kimi Code Assistant on Moonshot AI's platform lets you test the model's capabilities, while more hands-on experiments with agent swarm orchestration are possible via their GitHub repository, http://moonshot-ai, Kimi K26. Moonshot AI's Kimi K2.6 has the potential to transform software development, optimizing long-duration tasks and redefining collaboration in AI environments. AI systems are evolving rapidly, and with the advent of ReasoningBank, a new memory framework focused on leveraging both successes and failures, the path towards more adaptive learning is becoming clearer. ReasoningBank is at the forefront of this revolution, designed to help AI agents distill generalizable strategies that enhance their decision-making capabilities over time. The key innovation within ReasoningBank lies in its use of memory-aware test-time scaling, (MATS). This mechanism allows AI agents to retrieve relevant past experiences effectively, incorporating both successful and unsuccessful attempts into their learning process. Traditionally, memory frameworks concentrated primarily on storing raw interaction logs, often failing to utilize the full spectrum of experiences. In contrast, ReasoningBank's dual approach to analyzing experiences ensures a more holistic learning methodology. The architecture of ReasoningBank includes a structured memory bank where experiences are organized, coupled with adaptable reasoning mechanisms. These features ensure that AI agents can dynamically adapt their strategies in response to incoming information. This adaptability is particularly enhanced when ReasoningBank is integrated with existing AI models, such as large language models, LLMs, allowing for performance optimization based on a continuously evolving set of experiences. Though promising, ReasoningBank does face challenges, especially regarding its scalability across complex tasks and potential ethical implications in autonomous decision-making. One significant risk involves the potential misinterpretation of memory retrievals by AI agents, leading to flawed decisions that could perpetuate previous mistakes rather than correcting them. For those interested in exploring this technology further, the official blog by Google Research delves into the intricate details of ReasoningBank. Practical implementations and demos are available on platforms like Hugging Face, offering insights into how this framework can be operationalized effectively. With ReasoningBank, AI agents are poised to achieve unprecedented levels of adaptability, making strides in real-world applications by learning from their collective past experiences. This represents a significant shift towards more dynamic, self-evolving AI systems that require less human intervention, ultimately reducing operational costs and enhancing task efficiency. The rise of AI-driven document processing systems signifies a groundbreaking advancement in the automation of enterprise workflows. These systems employ sophisticated technologies such as optical character recognition, OCR, and natural language processing, NLP, to drastically reduce manual data entry, thereby minimizing errors and enhancing the capability for real-time decision-making. The automated document processing landscape is evolving rapidly, with key players like Amazon Web Services, AWS, introducing their intelligent document processing, IDP, solutions, which leverage generative AI to manage unstructured data efficiently. Companies such as Acodis and AutomateDataExtraction.com are at the forefront of this innovation, each claiming impressive reductions in operational costs and error rates. AutomateDataExtraction.com reports an 80-90% decrease in manual data entry, while Acodis boasts 90% time savings, aiming for zero errors in data handling. These AI-driven solutions can autonomously process diverse document types, transforming unstructured inputs into structured formats without the need for predefined templates. At the core of these systems is a blend of OCR and NLP techniques that allow them to classify and extract data continuously, a capability that is indispensable for companies seeking to boost efficiency. Integrating with cloud services, they can seamlessly monitor emails and document repositories, thus enhancing workflow automation. However, the journey towards full automation is not without its challenges. The accuracy of AI can be heavily influenced by document quality and complexity, which remains a significant factor for businesses considering these solutions. Moreover, data privacy concerns arise, particularly in automated environments handling sensitive information. To capitalize on this technological shift, enterprises can explore solutions like those offered by AutomateDataExtraction.com for insight into their processing pipeline, or delve into AWS's IDP service to understand the role of generative AI in document management. While AI-powered document processing promises a future where workflows are smarter and more efficient, it also allows human resources to focus on strategic, value-added tasks rather than time-consuming data entry. The implications for businesses are profound, with real-time insights facilitating improved operational efficiency and potentially reshaping business models to focus on activities that more directly impact the bottom line. The competitive edge provided by these systems can be significant, particularly for early adopters in industries where document management plays a critical role. Yet the careful evaluation of AI solutions is crucial to ensuring they deliver on vendor promises, as performance may vary across different real-world scenarios. Darwin-TTS 1.7b Cross by Seawolf AI is setting new benchmarks in text-to-speech (TTS) technology by incorporating cross-modal capabilities and emotional nuance. This groundbreaking model integrates 3% of the Qwen 3 1.7b LLM's weights to enhance emotional expressiveness without the need for large datasets. Technically, the model infuses a small portion of an LLM's neural network weights into TTS systems, enabling deep emotional understanding alongside language processing. This integration involves using feed-forward neural network (FFN) components within the model's architecture, facilitating a bridge between pure text-based learning and auditory emotional synthesis. By leveraging a deep learning structure designed to process emotional semantics, Darwin-TTS reduces the need for extensive pre-training on vast data, addressing a major bottleneck in TTS development. In terms of performance, Darwin-TTS 1.7b Cross operates with 1.7 billion parameters, achieving emotionally nuanced speech while maintaining zero additional training data requirements. This efficiency is further underscored by its ability to function without any additional GPU hours, a notable achievement when considering the computational demands typically associated with achieving similar levels of expressiveness in traditional TTS models. The model not only supports multilingual capabilities, but also outperforms many traditional models that demand extensive data sets and training to achieve equivalent enhancements. It stands out by maintaining high fidelity and coherence of speech, even as it introduces emotional variability, offering a leap forward in creating lifelike virtual interactions. Despite these advancements, Darwin-TTS faces challenges. The scalability of its approach to larger languages or dialects remains untested. Additionally, the potential to capture subtle emotional nuances across various cultural contexts might be limited, pointing towards potential improvements in model generalizability over time. These advancements also bring to the forefront ethical considerations, particularly concerning AI's role in simulating human-like emotional responses and the nuances related to eventual biases in emotional representation. To experiment with this model, you can explore Darwin-TTS 1.7b Cross-Modal /.co/a media Darwin-TTS 1.7 Cross AW4 item source OpenA on Hugging Face. The open source availability enhances its accessibility for research and application in multilingual, emotionally sensitive AI assistants, providing a practical avenue for developers to integrate sophisticated TTS capabilities into their projects. In brief, Darwin-TTS 1.7b-Cross heralds a future of more expressive human-computer interactions, marking a significant milestone in the pursuit of AI systems that can understand and convey human emotions with greater clarity and authenticity. Addressing the challenges of unstructured data governance in AI is critical as enterprises handle increasingly diverse formats like text, images, and IoT sensor data. With over 80 to 90% of enterprise data classified as unstructured, this presents a significant governance challenge. Effective governance frameworks are essential to manage this data correctly, ensuring not only compliance and security, but also maximizing the utility of data in AI applications. Unstructured data integration, UDI, offers an end-to-end workflow connecting to raw, unstructured data sources, applying governance principles crucial for proper management. This involves managing various file formats and adhering to data compliance requirements. Given the complexity, automated tools for efficient data discovery and classification have surged in importance. By automating these processes, organizations can ensure that data is well categorized and AI-ready. Automation in classifying and enriching unstructured data is pivotal, making it possible to transition vast amounts of data into actionable insights efficiently. This is particularly important when considering that less than 1% of unstructured data is currently utilized in generative AI applications, underscoring the untapped potential lying within existing data assets. In terms of implementation, leveraging resources from industry leaders like IBM or Calibra can provide organizations with advanced tools necessary for robust, unstructured data governance. These solutions can help organizations classify data accurately, safeguard sensitive information, and integrate data seamlessly into AI processes. Real-world implications of improved governance are numerous. It reduces risks associated with regulatory compliance and can prevent the mishandling of sensitive information, such as personally identifiable information, PII, or protected health information, PHI, often buried within unstructured data. Moreover, an effective governance framework can greatly increase the return on investment by unlocking hidden business value, enhancing AI outcomes, and driving operational efficiencies. The market for unstructured data governance tools is on the rise, driven by the growing necessity for AI readiness. However, balancing data accessibility with security remains a significant challenge, and organizations must weigh the scalability of governance frameworks as they handle rapidly expanding data. The effectiveness of specific frameworks is still being evaluated, with variability across industries in their adoption. To successfully navigate unstructured data governance, organizations should prioritize scalability, leverage automation for data management, and tactically address trade-offs between accessibility and security. By doing so, they not only mitigate risks, but also enhance the reliability and accuracy of AI outputs, positioning themselves ahead in the competitive AI landscape. The fragmented adoption of AI tools within law firms presents significant operational risks as the legal industry moves forward with these technologies. While over 50% of firms are either using or considering generative AI, only about 15% report measuring return on investment, ROI, from these tools. This underscores a critical gap in strategic planning and demonstrates the need for a more cohesive approach. Integration compatibility is essential for AI tools in legal firms. Many consumer-grade tools, despite their accessibility, pose potential malpractice risks due to accuracy rates of just 60 to 70%, in contrast to the 95% accuracy of professional-grade solutions. This difference not only impacts the reliability of the legal work produced, but also threatens compliance standards, thereby increasing the operational risks associated with AI adoption. To address these challenges, the need for a unified AI strategy within firms has become apparent. Such a strategy would enhance the overall effectiveness of AI tools, ensure compliance with legal standards, and reduce operational costs. Establishing oversight mechanisms can further mitigate risks by enforcing accountability and strategic deployment of AI tools across various practice areas. Law firms should actively develop and implement coherent strategies for AI adoption. This includes establishing guidelines to measure the performance and ROI of AI tools. Training and support programs focusing on professional-grade AI tools are critical to ensure users understand how to achieve the best outcomes, fulfill compliance requirements, and maintain high accuracy in their work. A strategic approach to AI adoption can significantly transform legal practices. It can enhance workflow efficiency, maintain client confidentiality, and uphold client trust, all while redefining the value proposition of legal services in a rapidly evolving digital landscape. This proactive stance on AI integration not only secures the competitive edge of law firms, but also grounds their technological advancements in a framework of accountability and excellence in service delivery. NVIDIA's innovative integration of FP8 precision in reinforcement learning (RL) training is set to revolutionize the speed and efficiency of model training processes. The introduction of FP8 precision marks a significant departure from traditional training methods, addressing computational and memory bottlenecks that often hinder the development of large-scale AI models. By transitioning to FP8 precision, NVIDIA has achieved training throughput improvements of up to 48%, translating to a speed boost ranging from 1.30x in smaller models like the Llama 3 8B to 1.53x in larger models such as the Llama 3.1 405B. These improvements are particularly potent for workloads involving large language models, LLMs, where training delays can significantly impact development timelines. The technical backbone of FP8 precision lies in its ability to maintain consistent precision across both training and generation phases, a critical factor in reducing the numerical discrepancies often encountered with BF16 methods. This consistency ensures that while throughput is increased, accuracy is not compromised, maintaining the integrity of model outputs even as precision is reduced. Incorporating FP8 quantization techniques also involves careful considerations of hardware compatibility. Not all GPUs may be equipped to handle FP8 operations optimally, potentially leading to variations in results across different hardware setups. As such, developers intending to leverage these advancements should ensure hardware readiness, particularly in the context of NVIDIA's NeMo-RL framework, which facilitates seamless integration and deployment of FP8 optimized models. For those interested in delving deeper into FP8 methodologies, NVIDIA's comprehensive NeMo-RL framework documentation docs.nvidia.com/nemo/rl/la fp8/fp8 source OpenAI serves as a valuable resource. Additionally, the FP8 RL paper /@org/eb/2601.p18 OpenAI provides an in-depth exploration of the quantization techniques and their application in reinforcement learning scenarios. The implications of transitioning to FP8 precision extend beyond mere performance gains. It offers a pathway to optimize resource utilization, enabling faster iteration cycles and efficient scaling of models. However, certain trade-offs remain under scrutiny. The application of FP8 precision needs further validation across diverse model architectures and real-world scenarios to fully understand long-term stability and performance implications. In summary, NVIDIA's FP8 precision in reinforcement learning not only promises a boost in training efficiency, but also sets the stage for broader acceptance of low-precision models, potentially reshaping AI development landscapes by offering faster, more cost-effective solutions. The future may see a shift in industry standards, prioritizing training efficiency alongside accuracy, as the competitive edge in AI continues to be defined by speed and innovation. Thanks for joining us on today's journey through the latest AI advancements. If these stories sparked your interest or inspired ideas, dive into the resources we mentioned. Keep exploring, keep creating, and stay tuned for more insights on the Daily AI Brief. Until next time, happy coding.